So I'm recording this session. Good to have you guys back here. Um, Today is going to be really fun and probably way too much information because we're going to do interfaces, then move on to functional interfaces, and then continue with Lambda expressions. So it's a lot to take in probably. So don't worry if you can't follow along. I'll post the videos on these topics later tonight and you can just see them and replay them for a bit. I'll add some additional resources as well. So don't worry, this is really hard. If you can't follow along the first time, that's absolutely normal. For some reason, I ran out of battery. All right. That always happens during trainings. Okay. I'm going to share my screen. Ugh, you didn't do your homework. Aha, so you dare to shut up, Leon. No, that's okay. That's also perfectly normal every now and then. All right. Once more, let me start the presentation. Then get Zoom back and share my screen. There we go. Come on. I can do this. I should be able to do this. Yes. Okay. So we've done a lot already because this is the 11th session we are having already. Also week 10 because we start to count from 0 because this is a Java course. So we must start to count from 0. And today we're going to talk about Lambda expressions and interfaces, and that's a lot. So don't worry too much once more if you can't follow along. I will post videos with more information and extra resources so you can see those. At the end of the session, I'll talk a bit more about the next steps because this, as you can see, is the last session of new topics. So at the end, I will talk a bit about the next steps. Please remind me of that in case I forget. So first things first, let's discuss the homework. I already got the notion that not everybody managed to do so, and that's very understandable. It's okay. Let me just show a bit of what you could have done if you were to do your homework. Did anyone else, did someone manage to do the homework? It's okay, I'm not taking it personal. Here we go. I mean, I didn't do the homework either. I was doing it in the session, right? So who am I to blame you guys for this? Yes, so the first thing I said was, instead of writing the things happening in a tournament to the screen, write them to a file. So even though some of you may not have done the homework, what should I use to write stuff to a file? What class can I use for that? I mean, there's multiple right answers here. Let me check the chat. File writer, yes. So you didn't even need to do your homework, Leon. You just know, you know it. Yeah, it's fine. So let's see where I'm writing something to the screen. So I can, I think in round, I'm probably writing something to the screen at some point. No, maybe in tournaments. I'm not writing a lot to the screen. What is this? Oh, this is a broken file. Oh, no, that was a toString method. Okay, so I'm going to restore part of this class. There we go. And I'm not, here I'm writing some sort of total goals to the screen. Let me just loop over the teams we're having in our tournament and write them to a file instead of to the screen. I'm pretty sure that was an exercise at some point. So we have 2 teams to our tournament. So this is going to be a very brief tournament, like 1 round and that's it. But that's okay. So first, I'm going to set the rounds of set the teams of the tournaments, and I'm going to insert a new array list in there. And then in here, I'm going to add team, and I'm also going to add team 2. And there we go. And then in here, I'm going to make a for each loop, and I'm going to loop over all the teams we're having in our tournament, and I'm going to print some data on these teams to a file. So let's say for every team in our tournament, there we go. And then here I'm going to make a file writer, or actually, I don't want to make file writer every time I'm in the loop, because that's just a waste of memory. Let's just do it above there. Remember what we also had to do when we were going to make a file writer? Look in the chat, no one's replying. Why is this red? What should I do? Yes, try catch. So file writer might throw a checked exception. So in order to do this, I would have to put all of this in a try block and catch the possible IO exception that might be thrown. IO exception E, and then let's just do print stack trace. There we go. And actually, I am going to use a try with resources, and I'm going to create our file writer inside our try with resources, so it will be auto close, which is good. So then here I have a file writer that is writing to a file we're not having yet, teaminfo.txt, which will be on the root of our tournament project. And I'm going to say for every team in our tournament, say file writer dot write, and then just go for the team, or what the T I call it, I guess, get name, because I think that's the only thing that's set actually. Well, maybe also do plus the, did I do some sort of toString override on here? No. Okay. And then I'm just going to say get class, so we can see what kind of team it is, whether it's a professional team or an amateur team. And in between there, I would like to have a space. And at the end, I would like a new line, so I can either say plus this here, or I could have said once more f w does write. What's wrong now? Oh, oops. There we go. This is much better. So if I'm going to run this, I expect it will create a file for me with the 2 teams in there, with their name and their class. And as you can see, a new file popped up over here. And we have 1 amateur team and 1 professional team. So this seems to be working, right? Then the next point of the homework was catch exceptions the correct way. Oh, well, I guess I kind of did that, sort of. Clearly could still be better, the error logging and stuff, but you'll learn that in live environments. And then I said, create your own checked exception that gets thrown when the game is starting without a ball. Who makes up this stuff? I'm not sure. But it says checked exception. And we had 2 exceptions. We had checked exception and unchecked exception. Checked exceptions, they were actually extending from another class than the unchecked exceptions. Checked exceptions, they were extending exception, and unchecked exceptions, they are extending runtime exception. So in this case, we need to we need to extend exception. So let's do this. So let's just call it game without ball exception, like this. And then here, we actually have to say extends exception. And if you remember correctly, we need to override 3 constructors here. We need to override the constructor that takes no arguments, that takes another exception as an argument, and it takes a string message as an argument. Well, as you guys might know, I'm somewhat lazy. So I'm just going to, there we go. There we go. And in here, I'm just going to say exception cause. Yeah. So I made the 3 constructors, and now I have made my own exception. Then it says that gets thrown when the game is starting without a ball. So I have to go to game. And in here, we have a play game method. So in order to do this, I would have a property ball, and it should probably be true or false. It's really silly, but still, I'm doing this now. I made you guys do this. And then here, I'm just going to say if ball, and then in here, I'm going to say throw new. There we go. What's wrong now? I am throwing a checked exception, right? So in here, I am going to say display game method. This is actually throwing a game without ball exception. And then in here, I'm calling this method, I think. Yes, so here I would have to do a try catch. I'm thinking what's prettiest. These try catch, they're usually quite ugly, but I am going to do this here, I guess, because I want to try this and catch the, there we go. And that was actually the next point, catch this exception in the place where you are starting games. So I am. There we go. So that was the homework for this week. Are there any questions about this? Yes, Leon. So we would probably want to make sure that that's because Leon is saying the default is false, and he's referring to this one, the Boolean here. So this, when you don't specify anything, this is going to be false, and it's private, so you can't even access it. So we probably want to force that whenever a game is being created, we have to say that the ball is true or something like that, or just putting this to true in here, and then by default it doesn't get thrown. Are there any other questions about the homework? No? Good. Then let's start with the interfaces. There we go. So I'm still sharing my screen, right? Yes, good, because the round around it is missing. So let's talk about interfaces. And interfaces, they are a bit like classes, but they're not really. Why not really? Well, like abstract classes, you cannot instantiate them. But unlike abstract classes, they can't have all sorts of members. For example, interfaces, they cannot have property variables. They can have constants, but not property variables. So they're different. What is the role of interfaces? Well, interfaces, they were to some extent added to make it possible to inherit from multiple places. So they are actually some sort of contract for a behavior usually. And classes, they don't extend interfaces, but they implement them. So interfaces, they usually contain abstract methods. And these abstract methods, they'll have to be implemented by the class that is implementing the interface. So let's have a look at an example. I think this is quite a famous example when you're taking animals as an example. Because some animals, they are predators, and some other animals, they are prey animals. So some animals, they will have to implement predator, some will have to implement prey, but quite many will actually have to implement both. Well, if we would not have interfaces, then we would have 3 different branches we would need, because we would need a branch for animals that were only predators, we would need one for animals that were only prey, and we would need one for animals that are actually both. But thanks to interfaces, we do not need this, because now we can actually say, if we have like animals over here and we have some cat-like animals over there and dog-like animals over here, and at some point we can just inject the predator behavior inside the tree. So we can just say, hey, from here, these animals, they are actually being predators. So they implement the predator interface. So let's have a look at the predator interface. It's over here, and it has one method. And this might look weird, because usually we have something like public or private or whatever in front of this method. But this is not a default method with no access modifier. Because it's inside an interface, it's implicitly public. So even though it doesn't say so, it is a public method. So if we want to override it later, we'll have to use the keyword public for it. I gave it a name. I just wanted to call it catch, but then I realized that catch is a protected keyword of Java. There's a bunch of protected keywords, and these are actually the words Java needs for its language. So words like if, words like public, words like interface, and also catch, because we have to try catch, so also try. So these words, you cannot use them as names for your own thing. So I went for catch indeed. And it's not returning anything. So then we have a dog over here, and this dog is a predator. So it's implementing predator. And here I'm saying that it's overriding this method. And if I'm not overriding this method, this dog class is actually not compiling. And here we have a parrot, which is some sort of bird, and it's a prey animal in this case. And it is overriding the method public void run and hide, because run and hide is specified inside the interface of prey. So it needs to implement this method. If a class is abstract, though, it doesn't need to implement these methods directly, but it is inheriting these abstract methods. So child classes that are concrete, so not abstract, that means, they would have to implement it. And then here we have a funny animal. It's, again, the parrot class, so that's just an addition to the bird I just made. But this is implementing both. And you see it's comma separated, and then you can just add different interfaces. And then you'll have to override both methods. Well, that's sort of how this is working. It's not much more complicated. It is possible for interface to have different members, though. So what members are possible? Well, it contains abstract methods, as we just saw. It can contain constants. So if we would just insert, I don't know, some sort of int I to our interface, it would be a constant, and this would also be implicit. So it would be public, static, and final implicitly. So even though we are just looking at the type and a name and a value, it's public, static, final. It can also contain methods with a body. It can contain default methods that have a body, and you can just call them on the class that's implementing the interface as if it were their own. You can have static methods with the body, and you are calling these on the interface, like you are for static methods on classes. You're not calling them on the instance, but you're calling them on the class. In this case, you're calling them on the interface. And I know we decided to do Java 8 in the beginning, but since Java 11, you can also add private methods in interfaces to avoid duplicate code. So here we see an example of the predator interface with a constant over here, int x equals 10. This is the case for all interfaces. I wouldn't know why you want to do this in this case, but you could. It has a default method, and here we have the keyword default in front of the method to specify that this is a default method. And as you can see, it has a body, and then we have a static method as well. And I really didn't have any inspiration for that, so I made this very lame method. But as you can see, it's static, and we can call it like a static method. Here we say predator, because it's the predator interface, dot static predator method. And the other ones, we are calling them on the instance, if that makes sense too. I see. I have some questions in the chats. that's a good question, Leon. So you're saying, since interfaces have default methods, why should you still use abstract classes? Well, classes, they are really objects that can exist and other classes can inherit from it. To some extent, just like interfaces, but different though. Classes, for example, they can have properties like a name, like we have the dog, we have the animal class and it's abstract, but we can add properties to it. And if it was an interface, we could not add properties to it. So that's one difference. And it also has to do a bit with the design. So with an interface, it's really a contract for behavior. And the animal class is not really a contract for behavior. It's just the top of our inheritance tree, so to say. Whereas the interfaces, they are usually more of a contract of behavior, but not always though. If you look at the collection framework in Java, we see, for example, that list and queue and map and set, they are really big things, yet they are interfaces. So this is why we very often say list something something equals new array list, because we cannot say new list since it's an interface, we cannot instantiate it. So to that extent, it's very similar. You cannot instantiate both. But the abstract class is really some sort of object ID, but then just a bit too vague to instantiate yet. Whereas interfaces, they can be really weird things as well. Actually, the collection framework is great to have a look at weird interfaces. Let's go there. Wait, let me just type this and then just go there. Oh. This, and then just go there. So here we see it's an interface and it's actually extending another interface. So classes, they cannot extend interfaces, but interfaces can extend other interfaces. And if we go to the collection framework, we can see that it extends yet another interface, iterable. And here's the interface iterable. And it actually has lots of child classes too. Let's see, because it's not a really funny one that I would like to. Maybe ArrayList is a really funny one. One that you really feel like, yeah, this should not be a class. Well, come on. For example, clonable or serializable. These are things that really aren't object-like. So especially the able classes. So clonable, serializable, you have more of these. This really doesn't feel like an object. This, to me, it really feels like an interface because it's really adding some sort of behavior to the class. Now it is clonable, or now it is serializable. And actually you also have marker interfaces. And this is an example. Because this one over here, it has no methods. So this is really just to mark a class as a promise to Java that you can use it in certain places. It might be too much in depth, but this is just added to make sure that at other places you can use the polymorphism thing to say you can only add clonable objects to this place. Let me remove this because I just had a project that was compiling, which was super cool. Yes. Any other questions about the interface? This is a really good question, though, and it can be a topic of much of discussion at the edge cases with your colleagues, where one of you might want an interface and the other one an abstract class. Very often you're both right or both wrong. I don't know. Ha! You have lots of discussion about that. Cool. Yes, it's just a matter of preference to some extent. Let's move on. Let's talk about functional interfaces. And then we're going to make a bridge to Lambdas, and I'm going to lose all of you, I'm afraid, but that's okay. As I said, it will take some getting used to nail the Lambda expressions. So a joke I'm always making is that they're called functional interfaces, and that starts with fun for a reason, but let's just see for yourself whether you think this is fun or not. Functional interfaces are special interfaces because they only have one abstract method. And you can annotate them, that's with the add sign on top, with functional interface. And that's actually a good practice if you really want to have a functional interface. And functional interfaces, they only have one abstract method, and you may wonder, what's the big deal? Because, okay, so it has one abstract method, I can see that. But this means that you can implement them with a Lambda expression. And this is where things might get a little weird. And it starts to look a lot like JavaScript. So I will put an elaborate video on this online, so don't worry too much if you don't get it at first. Here we have a public interface pray with only one method, void, run, and hide. If we want to say new pray, we are actually making an anonymous implementation of pray. So if we would just have some sort of animal, I don't know, a public class mouse implements pray, it's not an anonymous implementation anymore because we're adding it to our mouse class. And in here, there is no class. We're just making a new pray. We are implementing the method, and we cannot really say how or what or where. It's just an anonymous implementation. And it's a few lines. Because here you see that they say pray p equals new pray. We open a curly bracket and we close one. We close it over here. And then there's this really weird thing. We need a semicolon over here because this is actually considered one line. So Java just thinks this is one line statement. So we need to anti-line with a semicolon like we are used to. And then in here, I'm just going to say add override, and I'm overriding the methods. And then we have anonymous implementation. We can do this exact same thing with a Lambda expression, but then in one line and way less characters. So here I'm going to say, again, I'm going to give the type pray. I'm going to give it a name, and then I'm going to say equals. Then in here, I'm going to add the parameters that this method is taking, which in this case are none. So this is why there's just 2 parentheses. I'm having this weird arrow over here. So this and then becomes, and then this is what's happening. It's just a system out print line, semicolon, that's it. So since this pray has only one method, Java knows which one I'm meaning to override. And I can override it with this funky syntax. So here are the parameters. So whatever is here, if this would have a double B, for example, I would have to put in a B over there, and it would assume it's a double. You can add the double then over there, but you don't need it. So if there were parameters over here, you would need parameters over there. In here, you can have the arrow and then whatever is being returned, or if it's not returning anything, as in this case, whatever is being done. And then actually, if I would want to call this method, I would have to say p1.run and hide, and it would just print this line. That's pretty cool, right? Yeah, I thought that would be pretty cool. And it can also be very confusing because how does Java know all this? Well, it can just defer from the context what it needs to put on which positions to make the implementation. So it's just, to some extent, syntax sugar. And this is, well, I can imagine that right now it doesn't feel very useful yet. This is weird. Because Daniela is not in our session, or is she? Because she said she wouldn't come. And then I saw this blue line on my screen appearing with the tag Daniela next to it. So she might be here. Let's see. Is she here? Yes, she's here. Nice to have you here, Daniela. Please don't draw on my screen. So these built-in functional interfaces, they're making it very powerful because at some point we can use them to do actually the functional programming kind of thing. It's way too much for now, but you have all these built-in functional interfaces for common situations. For example, the predicate is really nice. It's a function that's returning a Boolean and that takes an argument. So many classes, they actually have a predicate as an input, or sorry, many methods, they actually have the predicate as an input type. So instead of having to create a predicate and then send it along, you can just send in a Lambda expression. It knows it takes a predicate, so it knows it has to turn this predicate into a Lambda, it has to take this Lambda expression, turn it into a predicate, and then you can send around methods all of a sudden, which is super cool. But yeah, you're probably, I'm going to add some cool readings to get you a bit more familiar with this, but this is really quite advanced and it will make much more sense, I don't know, half a year from now if you continue doing Java. Yeah, Leon is saying it's a bit hard for OCA. You would think so, but you need some of this knowledge for it. So, But that's the problem, I think, with what you need to know about lambdas for OCA. It's so little that it's super hard to actually see it in a context, see why it's useful, see why it's so powerful, and then you only understand it like a little bit. It's just a trick you know how to do. So it's better to understand it a bit more, so you understand it really well, so these questions are going to be super easy for you, right? I think that's a good strategy, usually. Any questions about lambda expressions? No, I still need to edit the video, but I will start editing the video right after the session and I'll put it online later tonight. It's quite extensive, so there will be more information on lambda expressions in there. Then actually, you're up already, but this is a bit different because last weeks we all had these homework, coding homework and stuff, and right now we don't have it. So for this week, all you'd have to do is familiarize yourself with these topics even further, do the readings, maybe rewatch some of the explanation, watch the videos. And then for as of next week on, we'll have one question in which we are going to see if you have a question about the homework, whether there are topics that are still vague to you, so you can pretty much ask anything next session. If you don't ask anything, I'm not going to tell anything. So if you want me to tell something, you need to prepare some questions. Then the 2 sessions after that, they are focused on exam preparations. And I still need to figure out how to do that without violating any copyright issues. So I might come up with my own questions for that in the meantime. But I will also advise you what tools you can use, how to prepare for the exam. And then again, if you have questions about questions that you came across and maybe inside a book that you've already bought, for example, please ask me and I can still explain them and help you to get along with that. Are there any questions right now for me? No? If you do happen to have questions during this week, please let me know under the videos and I'll try to help you. And then I wish you a really nice Saturday night. And I hope you're going to have fun with the lambda expressions. Bye-bye.